Good morning, students. Now, today we are going to discuss about polar curves. Given polar curves, the luminous intensity of a candle power from source assumed to be uniformly distributed over the surface, but no one of the practical lamp gives uniformly distributed light. Uniformly distributed light. The polar curve are drawn by taking the luminous intensities in various directions at an angles displacement in the sphere. We have two types of polar curves. Those are horizontal polar curve and vertical polar curve. Horizontal polar curve and vertical polar curve. Okay. The polar curves are used to determine mean horizontal candle power. Already we have discussed MHCP, mean horizontal candle power, and mean spherical candle power, and MHCP, mean horizontal candle power, MSCP and MHCP. Okay, to be determined by taking the mean value of candle power in horizontal direction, and MSP can be obtained by taking the average value of in all directions. The typical polar curves from a arbitrary facilitations is that, then see that figure, that is, and one is a vertical plane and another one is a horizontal plane. So vertical plane, it will be regarding the values started 0, 30, 60, 90, 120, 150, 180, and whereas for it will be taken as only for horizontal 0, 30, 60 and 90. Okay, so here thing is that mainly the polar curves are two types. One is horizontal plane and vertical plane. Horizontal and vertical plane both are going to be to determine the values of an MSCP and MHCP. That is the final intention of an polar curve. Why we are using for polar curves means simply you can determine the value of MSCP and MHCP. That's all. Okay. Next, Roussis's construction. Roussis's constructions. Okay. Roussis's construction. Suppose the vertical plane curve in the form of an two labels symmetrical about x-axis. Okay, about x-axis. Otherwise, the axis will taken as x0, x dash. Otherwise, y0, y dash. So as you wish, you can take. Okay, at a center point O. Okay, draw parallel to that, all equal in it. All the lines are going to be parallel to. So already we are discussed in vertical plane is consisting of 0, 30, 60, 90, 180 degrees. So regarding that degrees, we have to draw all parallel lines. Okay, draw any line of A. So see that picture, that figure is consisting of give that name, so like ABCD. So among that values is that polar curve at circular point in A or circle center A. Okay, at G is a gradient of an GH is equal to Y of. See that figure indication is the labels. That labels is consisting of from A to B or B to H. Okay, so from this vertical values or horizontal values, we need to find out the value of an MHCP. Okay, so among that one, the base is based upon that MSCP and MHCP concept. Mean ordinate of the curve is given by area of CZDBHLC is divided by length of OD. So whatever that vertical lines you are drawn from that figure, after drawing that lines, it will gives one symmetric representation. That representation will gives all the lines, that all the lines will be denote or indicate like A to Z. So whatever that letters, based upon that letters, we have to specify the value of an particular mean or ordinate value. Okay, the area under the curve can be either be determined a graph paper. I can be using a simple rule. So whatever that is, so this area can be written as in one particular graph paper. Otherwise, simply you can draw it in freehand only, no problem. Okay, Next, integrating sphere. Integrating sphere is a hollow sphere. It is one of the hollow sphere. Okay, and more in diameter, and inside the surface is potential. Why to make it is an diffusing as possible. Okay, there is a small windows on the surface fitted with that is a translucent glasses. A small screen is provided in order to prevent to lamp regarding that window directly. Just once you see that picture we have to explain that's all. The picture is consisting of a one lamp and the remaining is that kept as a one rectangular plane. That rectangular plane is consisting of a mirror prism and everything should be is kept in particular your diagram. Okay, this illumination is same in everything in a spherical surface and proportional to the light is emitted by the lamp, and it's proportional to MSCP. Proportional to MSCP the lamp. The brightness of the window is measured last by the last inside integrating sphere to the substandard luminance of an MSCP. Okay, the square of these distances are inversely proportional to the MSCP of the lamps. So among this integrating sphere is that the value of the distance is inversely proportional to that spheres. Okay, and next one is that lux meters of features. Lux meter of features. So now here it is an easy read about for this one. It is an easy read, easy to read out. And next one is that high accuracy. It will give an high accuracy. Next, measuring procedure. Press the power key to sum the mention of this one. The switch to desired lux range of this meter. I read the illumination value of this the displays whenever it will be is going to be an on position and off position. See that picture. That picture is consisting of an on and off key like it is a switch. Okay, we need to for this and measurement is completed of to turn off the device. Once we are going to be measure that device, after we are going to be turn off that device. Next, how it will be maintenance. How it will be maintenance. So to keep the instrument is clean. Okay, and next any maintenance and remaining should be is that maintained very neat and automatically the equipment will be is appearing very good and glow. Okay, next location and range of this particular recommended illuminations. That illumination is that conference, the value is that range 200 to 750 and pub room on 100 to 200 and instant corridor 150 to 200 and emergency treatment 750 to 1500 and lab and library the value is 2 by 7.2 750 to 1500 ampere. Next, source of light. Which type of source light? Natural source and artificial source. We have to use these two things, natural and artificial source. Okay, natural source in the sense sun, stars, but non-electrical source is that candles and lamps. Okay, this is about entire polar curves. Okay, thank you. We will see later next class.